How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to be diving into stub areas. Now, this is going to be an optimization of our OSPF environment as we continue to move forward in our OSPF section. So I'm not going to waste any real time getting into where we're at series-wise, because we're in the OSPF section. So what is a stub area? Well, first and foremost, it is a scaling function of two variables. So how complex is the topology graph? In other words, how many routers are in the area? How large of a flooding domain, large flooding domain means lots of SPF runs. So the lower amount of routers, or you really want to control how many routers are in your area. How much reachability information is there? How many routes are being advertised? Large routing table means it takes longer to flood. Scalability through reducing the two above. Now let's talk a little bit about, so the idea here is very simple. Let's be mindful of how many devices we have, and then let's be mindful of how many routes we're advertising. So think of it like this. If I have area 0 and I have, let's say, 20 routers inside of area 0, and attached to area 0 I have, let's say, 8 of those 20 routers have connections to other areas. Well, remember what we talked about with single area OSPF? The area itself does the OSPF calculation, right? So SPF is run on type 1 and type 1 LSAs. If that information goes to an area border router, so a router that's got an interface in a non-backbone area, area 1 through whatever, what will end up happening is the ABR will announce to the other area say 1 for example, I have routes in area 0, and it generates a type 3 LSA into the other area, so the area 1. The type 3 LSAs don't get an SPF run. Now, area 1 has its own SPF process that gets run for area 1 routes. Area 0 does the exact same thing. And you're going to have pointers to each one. Area 0 is going to have type 3 LSA routes from the ABR to get to area 1 and vice versa. If there's a lot of routing information being propagated, this could be potentially a bad thing. So if I want, a lot of customers that I've worked with, we will try to scale that. We'll say, okay, does your distribution layer switch need to see all of the routes from the core? No, it doesn't. So what would you do in order to prevent that from happening? Well, very simply, we would go in and we would configure them as a stub router. So the stub, you would only propagate what you need to propagate, which is just a default route. The stub areas don't need anything more than a default route to point to the core. The core knows about all the routes. The core is going to have all the routes in its routing table, but the distribution layer switches, they do not need to have any of that. So in this particular case here, we are trying to control both the amount of flooding that happens and the reachability information. How much information is actually needed in order to get to where you got to go? Well, the simple answer is just a default route, right? All we need is a default route on our distribution layer switch to point to the core. Once the core gets it, the core is going to have more specific routes in order to get somewhere. That's essentially what the stub is trying to accomplish, is to limit the amount of flooding that happens in its area. So when we talk about that, topology summarization is achieved through OSPF areas. So hide the details of how the graph looks in other areas, type 3 LSAs. You only run SPF for intra-area destinations, your type 1 LSAs. Areas don't hide reachability information. You're still going to see the routes, right? You're still going to see the routes themselves. However, you're not going to run SPF on them. If you see type 3 LSAs, the OSPF-inter if you're on Nexus, or the O-IA routes on iOS and iOS XE, you're not going to run SPF on those because they've already been figured out. The ABR knows how to get to them. The ABR is advertising them into your area. So because the ABR is advertising them into your area, you don't need to worry about anything. So that's why I talk about, that's why it's written the way that it's written. You don't have to do an SPF calculation on routes that are advertised to you by an ABR, because that's already been done. Now, NLRI, network layer reachability information summarization, reduces the number of routes. It takes multiple longer match prefixes and combines them into smaller, shorter matches. OSPF summarization is implemented in two different ways. We have per prefix summarization, right, where two routes of 10/10000/16 can become a single 10/15. And then you have per LSA summarization. Remove all inter-area routes and replace them with the shortest match possible, a default route. And this is what is done. So you can do both. You can go in and say, I want to do a summary. So you can go to the ABR and say any routes that are coming out of area 0 going into area 1, I want to summarize them down to a single 10/8, for example. Now, that's one way of doing it. Or you could use the stub no summary option and propagate just a default. So we're going to take a look at both and how that comes into play. So summarization and stubs are technically two different concepts, but they can live in the same area. No pun intended. So how stubs work. So filtering is enforced at a common transit point in the OSPF topology, the area border router. ABRs control which LSAs enter the area. You have type 3 and type 4, so type 3 being your area border network advertisement. Type 4 is going to be your ABR reachability to an ASBR. And 5 is going to be an area 0, and you have a type 5 LSA to get to your external route. Are filtered depending on the stub type. So reachability information removed and is replaced with the default route. Still allows reachability to remove routes in most cases. So that's going to be your route information reduction is going to be the default route. So instead of having a bunch of longer match /24s, you're going to have a single default route. All routers in the area must agree on the stub flag. So we'll take a look at exactly what that looks like as well. This is part of the adjacency negotiation. So there are 4 different types of stubs that we're going to talk about. You have the regular stub, which is stops external routes of type 5 LSAs. So you'll see type 5 LSAs will no longer be allowed in the stub area. Then you have a totally stubby area. Stops inter-area and external routes. So you have type 3 and or type 5, type 3 and or 4 and type 5 LSAs. You're more than likely, you're going to have this in most cases, or just about all the time if you're doing inter-area routing, and then you're going to have type 4 if you have an ABR that gets you to a different area that has a type 5 LSA or an external route to another routing domain, whether it's the internet, a default route, EIGRP, BGP, whatever it might be. And obviously type 5s exist inside of non-stub areas as an external route. So what's the difference between stub and totally stub? Well, a stub area, if you do just a stub, and I'm going to demo this here in just a minute so you guys can see what this looks like. If you have just a stub, you're going to remove your type 5 LSA and replace it with just the default route. So instead of going through and talking about them all in detail first, I'm going to demo each one first. So what I'm going to do is I'm going to come over here, and we're going to start this on XR41 and switch 7, N49 and switch 8. So we're going to go get that configured first. Let's go ahead and pull up this config. So first things first, XR41. Actually, let me do this on switch 7 and switch 8 so you guys can see the iOS variation first. It's very, very straightforward, so it's not like you guys are going to be seeing anything extravagant here. So let's go log in. So what we're going to do is I'm going to do show run pipe section OSPF. Now what I want to do, actually let me do just a touch of cleanup here. I'm going to go underneath here and I'm going to type in no and remove this command right here. Alright, so that's cleaning up OSPF. So conceptually speaking, what I just did is I removed any possibility of a interface getting plugged in, or a an SPI or a loopback address getting created on the switch and then inadvertently being advertised into OSPF. So what we're going to do is we're going to type in here, since we're on area 10, we're going to type in area 10 question mark. And if you look right here, you've got stub, right? So we hit area 10 stub. Now we have options here doing no summary and things like that, but that's not where we would want to run this command. We want to be a stub, right? So switch 7 is going to become a stub. Now it's going to take the adjacency down. And we're going to do the same thing on switch 8. Do show run pipe section OSPF. We're going to do the same thing in here. So router OSPF 1. I'm going to pull this network statement out here. Now we have this network statement here as well, but that's for the loop VLAN 10 and VLAN 11. So I'm going to type in area 10 stub. Okay. Now what I'm going to do, actually one second, let me pull that out. Bring the adjacency back up, because I want you guys to see the before and after. That should form an adjacency here with N49 here momentarily. There it goes. So do show IP route. And it'll take a moment for, okay. So what I want you guys to see is we have our default route, our E1 route, right? And we have all of our type 3 LSAs. These are all type 3s. OSPF inter-area routes are type 3s. All these are type 3s. Okay, so what I'm going to do is I'm going to type in area 10 stub. And now I'm going to go over to XR41, and here we had a squawk, dead timer. It doesn't specifically tell us why, but we'd have to debug it. So we're going to log in as Rob and Cisco, go to global config, router OSPF 1, area 10, and then we're going to use the command stub and hit the enter key. So I'm going to go ahead and commit that. That should bring my adjacency with 7 back online. So if I go back to 7, I have my adjacency again. And now what will end up happening is I will do a show IP route, and what I will get instead, notice how I still have all my type 3 LSAs, right? But now I just have a default route instead of a E1 route. Now if I go over to N49, and I will log in here real quick. Big T router OSPF 1 area 10 stub. Okay, now that that's done, go back to switch 8. The adjacency is back online. Do show IP route. Once OSPF has had a chance to recalculate, there it goes. Now I have my default route. I no longer have my E1 path, right? Now, and this is because switch 7 and switch 8 are now configured as stub routers. So they are only going to, they're going to get all the longer match internal routes, but they're only going to get a default route for external routing. Now if I go to XR41 and I do a do show IP route, I'm going to have an E1 route, right? Because this is area 0. So because he's got a default route via metro type E1, external type 1, he is a stub router, but he is on area 0, and XR41 to switch 7, that's area 10. So if we look at our topology here, remember we have area 10 sitting right here. So area 10 sits on 10.741, 10.849. This is where OSPF area 10 sits. Now because of that, what I could do, take this a step further. Now, most of my customers, when I discuss this with them, it's like, yep, if you're on the distribution layer and this is what you want to accomplish, you know, stub would get the job done. Now here's the let's talk about stub no summary now. So the totally stubby area, stops inter-area and external routes, so type 3 and or type 4 and type 5. Now what that means is that we're going to remove all the type 3 LSAs. So all those O space IA routes that you're seeing, they'll go away too. Like they'll be gone. So what we're going to do, and so what you do is you go onto the top end router. So in this case, your core or your core router, and you advertise that one as a no summary. So what that no summary command is going to do is it's going to say, okay, let's go ahead and not advertise you a summary address and only a default route. So switch 7 and switch 8 have really no need to know about all the inter-area routes that are going on. You just need to go through and advertise the default up from switch 7 and switch 8. I'm sorry, from 41 and 49 down to switch 7 and switch 8. So that's exactly what we're going to go do now, since you can see that. So before and after, let's go ahead onto XR41. And since we're underneath this guy already, and we're here, we're going to type in stub and then no summary. So do not send summary LSA into stub area. Don't send type 3 LSAs. I'm going to go ahead and commit that. And then that's going to resync the neighbor. Force GCC to go down. Same thing with 49. I'm going to hit up under here and type in area stub, no summary. And hit the enter key. So 41 should be back up. Perfect. Again, if I do a show IP route here, we still have everything. Now if I go back to switch 7, let me scoot this over just a touch. If I go to switch 7 now and hit the up arrow, all I have is a default route. I have no longer match routes. Same thing with switch 8. Do I show IP route? All those longer match routes, they go away. And the question is, do I still have reachability to everything? Yeah, I do. Well, can you prove it? Sure can. Let's go ahead and do a little bit of testing. So the first thing I'm going to do is I'm going to come down here. I'm going to pull up our PCs, and we're going to, we're going to do a show IP interface brief. We still have an IP address. We're going to ping, let's ping 1.26.33.26. Okay, I can still get out to the internet. I haven't showed you guys DNS yet and how to do Google or anything like that, or set up the internet routers. We'll come to that at a later point in time. So we have that. So what about router 25? Can I ping 10.0.0.25? Yeah, I can ping that as well. Now, is there any drawback to doing this? Not really, no. I've worked with plenty of customers that have this in place as a long-term solution. So just to recap what we did, so that you guys are tracking here, is we went to switch, let me go ahead and minimize this one. So what we did on the distribution layer switches is, remember this is distribution layer, right? Do show run pipe section OSPF. All we did is say, for area 10, make us a stub. On both switch 7 and switch 8. On XR41, we said do show run router OSPF. We're saying for area 10, treat it as a stub, but don't send a summary, any summaries, any type 3 LSAs down to switch 7. Now if I go back to switch 7, I do a show IP OSPF database, I literally only have a default route. I have it's kind of funny how it shows up. It's a summary, but it's a default route summary. So that's essentially where this would come into play. So it's not a type 5 external. Remember, that's the thing you got to remember here. You're not going to see a type 5 LSA here. You're going to see a type 3. Why are you not going to see type 5? Because type 5 LSAs are not allowed in stubs. You can only have type 3, type 1, or type 2. So because you can only allow a type 3 LSA in a stub, we have to generate a type 3 LSA, a summary net link state, which is what this is. This is a type 3 LSA that's been generated as a default route. Now, how would you do this if you were not to do stub routing. I'm going to take a look at that in a, well, since I'm done with this particular stub type, we'll take a look at doing redistribution, where that's where the NSSA would come into play. And we'll take a look at exactly how that comes into play over here in switch 13 and R34 and all that type of stuff. We have to go through and understand how that piece comes into play. I really can't do that here because, I mean, I could do a, you know, say that there's like I could simulate, like there's an external connection coming in here where we've got like a internet circuit, or, you know, we got, you know, we're doing a merger or an acquisition, something like that. But you would do that at the area level as well. So on, say, 41, underneath here, I would type in, now at the bottom here, we should have a summary in. I might have to go to the interface level to do this. Summary. Yeah, I might have to go to area. Sorry, it would be area 0. And then I would do, is it interface level? Interface 00002. And then summary. I know where it's, I know how to do it in iOS. XR is a little bit funky. What about 49? So you would do area 10, and then you do a range command. Is that what I'm looking for? Is the range command on 41? Let me exit out of here. I think it might be the area level. Is the range? Oh yeah, okay, here it is. Range, and then if you wanted to do summary, you'd use the range command. And you'd say, okay, I want to allow this summary to come through. So I haven't tested this out, so what I'm gonna go do is I'm gonna type in no this. We're gonna pull out the no summary. So commit that. Show config failed. Yeah, so we're gonna, oh, I see what happened. So we're gonna say abort router OSPF 1 area 10. And so we go back to switch 7, and if I look at my show IP route, oh, it didn't take. That's why. We're gonna say no stub, no summary. Okay, so that'll affect that. Now 7 will, as soon as the trigger comes through, that might take a moment or two. Do show run router OSPF. Oh, I see. Okay, so it did do that. So area, so we're gonna just say stub. It's kind of weird how that happens. It if you take out the complete stub command, it removes it. I don't think that happens in iOS. I think you can be specific with it. So on switch 7, we have our adjacency. Database fully loads now. And now we have everything back, right? We have our OSPF inter-area route, the default. So what I want to do is I want to take all these routes right here and summarize them down into a single advertisement, right? So I'll do a 10 splat. So what I'll do is on our XR41, the intention here is to do a range command, range. We're going to say 10.0.0.0/8. And then we're going to say advertise. I think it's the default. So I'm going to go ahead and commit that. So the intention here is on 7 is to get a 10 splat. I don't know if I did that right or not. Back to 41. Do show run router OSPF. I might have to go to area. So I know in iOS it's, let's pull this out and do just a commit for that. Let's see if that makes any difference. Do show run router OSPF. So we just have the, okay, it does it by default. So the intention is to try to get those /32 routes, all these guys, to go away. Let's try this on N49. So I would do area 10 range, and then it's going to be 10.0.0.0/8. And actually, you know what? I think this might be going the opposite direction. I think it's going from the source area. I think that's what I'm doing wrong. Let's go to do show IP route. Oh, that's because N49 still has the no summary command in place. So let's go ahead and pull this out. Show run OSPF. Area 10 stub. Okay, it's still there. So let's go back to 8. Okay, so yep, I think I know what the problem is. Let's go back to, let's try this in 49 first. So I want to type in no and pull this command out. I think this is where I'm making a mistake. So I want to go on this box. I want to type in area. This, I think it's the source area. Area 0 range and 10.0.0.0/8. Let's see if that has the effect. I think that's what I'm supposed to do. Yes, that did it. So I want to take and only advertise the /8. Now it's not going to get rid of the longer match routes, right? Now the reality of it is you're not going to do both. You're not going to do a stub and a summary at the exact same time. It's one or the other. I'm just showing you that you could do both, but it doesn't make any sense, right? Why would you do a stub and a summary route at the exact same time? You wouldn't. So I don't think it's going to get rid of the longer match routes. Yeah, they're going to stay. How you would get rid of this right here is to do what we already have done, right? You would go and you would do a no summary command, which would get rid of all these routes, right? You get rid of all the type 3 LSAs and replace them with just a default route from your type 3 LSAs. Because this is still a type 3 LSA, right? We're just summarizing it. So if I was to go over to, say, XR41 and do the exact same thing, exit out of here, do show run router OSPF, and say no, I think it was area 10. That area 10, no, we need to go underneath area 0. Commit that, exit out, area 0, advertise, range, 10.0.0.0/8. Commit, and now go back down to 7. And there's, okay, there it is. So it is working the way we expect it to, right? So we're advertising this default route here. I'm sorry, this 10/8 summary. But again, like I said just a second ago, you would never do this in production. This would never, you would never do both a stub and a summary address. Where you would do this is you would, if you weren't doing stubs for whatever reason, you can't do a stub for whatever reason, then the summarization, so if you can't do stubs, where would you do this? Well, I would do this over, if I'm running OSPF over DMBPN, I would do a summary, where I don't want to have 10,000 routes coming across my tunnel to my remote sites. I just want to advertise, say, RFC 1918, right? So your 10.172.16 and your 192.168 routes over the tunnel to your remote location, that would be a viable solution. Go to the tunnel, do your summary command, go to, I'm sorry, not the tunnel level. That's how you do it with the IGRP. You would go to your area, but you'd have to make sure that you're doing multiple areas in order for this to work, because you can't summarize wherever you want in OSPF. You have to do it either on an ABR or on an ASBR. You have two choices. So that's essentially what you would end up doing. So now that we've seen what the configuration looks like, conceptually it probably makes a lot more sense. So that's essentially where you would want to do that. So on 41, I'm going to pull this out. This doesn't make any sense. I just did it for demonstration purposes, so you guys can see what that looked like. So area 10, stub, no summary. I'm going to commit that. I'm going to go back over here to 49, do the exact same thing. So pull this out, and then area 10, stub, no summary. Okay, so 7 and 8 should both get updates. We had just our default route. Just our default route. Perfect. So that, ladies and gentlemen, is how you would do stub routing and all the cool things that go along with it. So in the next video, we're going to take a look at the not so stubby area and how that comes into play and stuff like that, because it's definitely going to be something you're going to want to pay attention to. So if you guys have any questions, comments, concerns, feedback, please leave a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you people in the next video.